Dmitrii will talk about Helix AI, it is. About this very nice title, Tamper-proof messaging and hybrid Web3 stacks. Whatever that means, I am very excited.
So thank you for such a warm welcoming. So I'm Dmitrii, I'm Chief Scientist at Helix. So first of all, subscribe to our Telegram channel, like Twitter as well. So today I'm going to talk about tamper-proof messaging, whatever it is, and hybrid Web3 stacks. So I'm going to be like a bit more general in comparison to the previous talk, but also more like kind of use case oriented. So we start with the basics, like with Satoshi. So if you remember that Satoshi Nakamoto never actually used the B word, like the blockchain word in the Bitcoin white paper. It was actually introduced later on, and what he actually called this thing a timestamp server. So he explicitly writes there, so the solution for the electronic cash begins with a timestamping server. And this is actually the initial point to depart from. And our goal was to actually reconsider the design itself rather than trying to, for example, build another Ethereum killer with a million TPS, but rather like to be sort of contrarian here and understand what we can actually derive from the original idea. So why actually it is called a timestamp server? Because the Bitcoin network uses this hash clock based on the proof of work and the difficulty levels in order to achieve a global ordering of the transaction log. And thus, once you have a global ordering everyone agrees on, you can prevent double spending of BTCs. So from the distributed systems point of view, Bitcoin is AP, like in like CAP, like cap theorem, it's actually AP system. So it is available, which means that you can always submit a transaction to a full node. It is partition tolerant, so even if the network is partitioned, it continues to function, but only eventually consistent, which means that if you if the network heals after the partition, then there is a reconciliation process, and there is this famous rule which actually tells you how to reconcile. Actually, it is as simple as choosing the longest hash, the longest difficulty level, and this is why it is eventually consistent. And then, due to the game theory there, and like one CPU, one vote mechanics, it is not very hard to show that as long as you have many confirmations, the probability that you will change your local view after the reconciliation drops exponentially. So you actually have a very secure system here. So on the other hand, in many situations, we don't really care that much about money, and Bitcoin and all the successors, like all these B words, were really inherently about cash transfers. So it was never about data payloads and like what is called zero-value transactions. It was always optimized and designed to facilitate peer-to-peer payments, so that you can very secure and censorship-resistant way give some Bitcoin to your friend, right? And putting data into Bitcoin was sort of a non sequitur later on, because people understood that, okay, this is a highly available system, it is highly replicated, then that it is safe, but there is so big overheads that actually it's pretty much impractical. But so this was like the starting point. And we decided that, okay, we want to start with the these premises, so we want to have a highly available system so that we actually more about data, so that you can actually send mostly data transactions, and we are partition tolerant, available, and also eventually consistent, but and the reconciliation process is powered by the Helix mesh consensus. So when I say like a messaging broker, like Litter's messaging broker, it means that everyone in the system can submit a transaction, which is typically just a data payload, and the receiver will, so this message goes through the Helix network, and everyone in the network will see that this message has been sent at that particular time and that it has been delivered, even if the recipient is offline. So how does it compare to the blockchains? So actually, in order to optimize for throughput and the data, we ditched the whole idea of having global ordering of transactions, but rather the only thing that matters here is the timestamp here. And the timestamping here is powered not by proof of work, but by the assumption that most of the nodes have synchronized clocks with UTC. Synchronized, I mean approximately sync, because you never can have ideal synchronization, but it is fairly safe to assume that they're like within 1 second. So if we have what we call round, and basically the consensus here is that a set of transactions without any particular ordering within the set is achieved, it means that all, for example, transactions in this block were submitted no later than this time, because the majority of the network have seen these transactions before this time. And we have like a discrete intervals where the network timestamps the delivery of these messages and acts as a broker. So this seems like a very simplistic thing comparing to all the smart contracts and all the modern blockchain with interoperability and like with the whole idea that you want to put all your processes on the blockchain and trying to automate this. But the point is that according to our talks with like our industry partners and like lots of research in the space, it is fairly clear that B2B use cases are genuinely different from the cash and DeFi. Because here, like, what are the main points of having like very secure smart contracts for cash and DeFi? Because what you want here is like to be censorship resistant. You want to be anonymous, so the full nodes are anonymous, and you cannot track any transaction. It is also autonomous, which actually means that whenever we send a transaction, it is automatically executed without any actors being involved. It, as a consequence, leads to only use cases were really closed within the ecosystem, which means that, for example, on-chain rewards and economic incentives to run the node must actually accept the native coin as the reward and on-chain reward mechanics, because you cannot actually assume that there is anything outside of the system. And if you go as far as like to introduce sharding and scaling, then data availability becomes a very hard problem, because if you do not have all your state on a single node, you have to somehow be sure that someone else in the network has the rest of the state and all the data. And as long as everything is anonymous and like completely trustless, it is actually quite hard, and you always should rely on some like soft things like economic incentives, like slashing, and this is actually a very hard thing to do. But for B2B use cases, the whole setting is actually quite different. So what is like a real pain point there? It's not actually about being censorship resistant, because once you're like a big enterprise and a vendor, typically you always have access to internal database. It's just like not the case that you kind of afraid that your AWS operator or like your ISP provider for some reason will block your business transactions because you're not like dealing on the Silk Road. It's not actually that case. But what is valued here is that you're accessible and highly available, meaning that you can access this network even within different data silos in the different regions. It is auditable, so you can actually show your audit trails and all your data to the regulators and to your business partners. You can assume that the vendors who actually typically will run the full node are mostly trustworthy. Mostly, I mean, in the sense that, for example, if you have like set up like a local mesh network when you have, for example, 2 or 3 vendors. This would typically be enough in order to conclude that 2 of these vendors are not malicious and 1 may be actually acting in an adversarial way. And also the adversarial way here is typically not like mingling with the code, but rather like being unavailable. So it is a very hard to imagine situation when a vendor who actually has this soft reputation on stake, because this is actually their business, will try to mingle with the system. Another point here is that even if there are some problems with that, since the vendors and the node operators are not really anonymous, if you have all the data on-chain and like auditable, then you have a very strong leverage, and you can use off-chain and legal system in order to actually initiate the litigation process. And moreover, if you have such a system, most of the time you would actually see off-chain cash settlements between the B2B counterparties, because this is actually how their processes work. They already have their accounting system, and they will hardly change anything there. And like a punchline here is that in order to succeed with business adoption, you really need to be like an overlay layer, meaning that your protocol and blockchain solution is non-intrusive. You cannot really convince your business partner to break down the business processes that work and put them into some very experimental smart contract platform. Rather, they would try to use them both for many reasons, not only from the technical point of view, but also from the managerial point of view. So that's why our motto is just like be very slim and non-intrusive, pretty much like I am here. I'm slim and non-intrusive. So that was like a general introduction. I was originally trying to be more technical on the like an architectural point of view, because this is, I think, something that is typically overlooked, and people like silently assume that, okay, here our like wonderful blockchain platform, we put everything there and nothing exists outside of it. But this is never the case, because typically you have IPFS node, Infura, everything like centralized DBs and everything. So originally I wanted to talk about like this kind of Web3 stack, as people put in there, but instead I will just give an illustration how you can actually combine different stuff in order and how we actually do this ourselves. So here is our Helix full node, which have different components. So we have like a core here, which actually isn't here, like a full node running the ledger database and like peer-to-peer transaction processes. It exposed an API endpoint, which is used by the wallet through the SDK. And since in our setup, we assume that the vendor is trusted and never censors the transaction, this actually is quite a secure setup already, because you cannot sign a transaction on behalf of your client as long as you don't do any custody. But everything else is already in this thing. On the other hand, you have like load balancer in order to facilitate lots of transactions, and you can subscribe through ZMQ provider on the messages, because we are like a globally available messaging broker. We actually expose all our APIs through the ZMQ. And ZMQ is actually our sort of role model, because this is very simple to use, and I will not even show you any like specific SDK comments, because this is like fairly trivial, and it takes only 1 hour like to understand how you actually connect to the broker, because whatever, basically all you need is just like API endpoint, and you go as we typically would do with like ZMQ thing. Also, we have this kind of weird things like relay providers and nominees here. So these relay providers are just nodes who do not accept client transactions, but rather relay transactions in the peer-to-peer network. And since we have this special relay nodes, the number of hops is always bounded, so we have actually quite fast, quite small latency. And again, in a Bitcoin or like Ethereum network, you wouldn't typically assume that you have like any sort of assumptions about the network topology. But when you're like more in the B2B case, it is fairly safe that you actually have your relay nodes in the network, and if for some reason it stopped working, you always have a gossip networking as a fallback. But typically it will work and you have very small latency here. And finally we have here like nominees and like Aragon, and this swap contract is actually Helix DAO, and this is actually our fledgling government setup, and originally it is used only in order to facilitate cross-chain swaps from native coin HLX to Ethereum, so that once you submit a swap request, nominees observe this transaction in our native network and approve it through the Helix DAO process, so that the coins are minted in Ethereum. And this kind of wonderful composability allows us first like to upgrade the contracts when necessary and also experiment quite a lot, because our Helix network 1.0, which we launched at the end of September, is more like an MVP, because it's actually proof of authority and yeah. Yeah, here it is.
Should I stand here?
Yeah. Yeah, so we have a proof of authority network, so all the key components from the Helix test consensus protocol are in there, but we can manually experiment and tune many things without actually going astray. Yeah, so the moral from this picture is that as a integrator and a blockchain engineer, you always should think about the whole ecosystem rather than trying to focus and like put all your sort of mind share in a single dApp or like a platform. Okay, so now we come to like real use case, which it was actually studied by Accenture, like in 2018-2019, and the problem is that we all know about overfishing, and tuna is consumed like crazy, and like fish die out, and we want to have sure that if you want to some fancy coffee shop here in Berlin, then the tuna sandwich that we eat is actually ethically sourced, and we don't support like crazy parties, whatever. So it turns out that 30% of the whole tuna in the world is catched in Indonesia, and it's not the most technical developed country, unfortunately. So the whole process from the catching boat to your favorite avocado store and tuna store is actually quite long. So we have like vessels, like in a port, and then we have a broker, and then it processes this, then there are a mixing of batches of the tuna, and then they go to the export. This is actually a US specific thing, and then there is like paper documents and confirmed chain and custody. So it is actually quite difficult to track the whole supply chain, and mostly the challenge here is in this part, because this part is already quite automated. So how would you do this? How would you solve this chain supply problem in order to track? Actually, the key challenge, as I said, is the lack of digitalization and unreliable data at the catch site, because typically people actually take papers, write something, and then submit it. Some data is lost, some data is malfunctioning. If someone tells you that, okay, we'll put our blockchain solution there, it resolves sourceability problem, they will lie. Because I can always put my temperature sensor in the fridge at my home, and it will happily submit very nice transactions that I have like 5 degrees, and blockchain will be happy about that, and but I will still like having everything astray. And the same with the tuna. I can take RFID on some single fish and then catch, for example, 10 kilos of fish just off the shelf, and no one will ever detect this on the blockchain. So how would actually Helix help with this problem? Because as you see, this is not really a technical problem, but also integration and social problem here. And the key factor here is actually the amount of data and the availability of this data. So if you have a fishing boat, And on this fishing boat, you have lots of sensors, such as GPS tracker, like weight tracker, RFID sensors on each fish. You cannot fool every single sensor, but as long as all these sensors submit very granular data, which is actually attested by the Helix network, you can build a very complicated data audit and analysis on this and actually detect the fraud. Because actually this kind of things can only work if you do some data science on this, and if you have just a single sensor, it's impossible. And the point is that if you just put like a hash on your data on blockchain on Ethereum, typically this data is just not granular enough, and you don't have enough data to have any meaningful conclusion. First, because it's actually off-chain, and second, it is not granular enough. So we actually have it accessible from everywhere, so the audit can be actually done from any other authority, even for example on the US. The US authority will be able to access all the data directly from the fishing boat in Indonesia, and then it will decide itself whether it is ethically sourced or not. And this is actually like a complex problems, but there is like a clear path to the solutions, because we at Helix Network work with the vendors and onboard them as partnerships, so they actually shield they do the field installation, and they shield all the crypto stuff from the end customers. So for example, the fishermen will never be exposed to the crypto stuff at all. They will just have a single mobile app and the sensors, but the vendor will facilitate the data delivery and authenticity to all the partners without even having a partnership with all the participants in the network. So this is actually like a win-win situation, and the vendors are actually our target audience to run our full nodes and integrate it. And again, as a slim and non-intrusive protocol, we do not assume that the solution itself will be built only on Helix. Typically, there will be lots of other infrastructure, possibly centralized and decentralized, but the key thing that whenever you have this data, but typically actually it will be like metadata, but on a very granular level, so that everyone can access this data and ensure that this data has been submitted at that particular time interval up to 5 seconds. Okay, so do I have time?
25 minutes.
Okay, yeah, so yeah, okay, then I will just mention, I can go, so right now it's like all about like complex systems, but you guys are mostly developers here, and I would suggest you like just to think about how would you use a system like a message broker, which is globally available. Anyone can connect it, pretty much like sending Bitcoin transaction, and we just put a timestamp and make this data accessible to everything. I, for example, have a very simple solution which will be retail facing and already solve like many problems. For example, everyone knows about Twitter trolls, and if you just have some trader who will say, okay, I bought Bitcoin, I sold Bitcoin on top and bought it at the bottom, and typically there is no way to nail it down and say, sorry, you just like cooked up your tweet just like 5 seconds ago. Basically, what you need is facilitate PGP encryption so that people actually can easily use it from, for example, our wallet or your wallet in one click. So this message is PGP encrypted. The PGP public key should be easily available, and actually you can even imprint this PGP signature into the profile pic using some steganography things, so that even if you take a screenshot, it will be available. And so this requires no blockchain whatsoever so far, just like PGP signing, so you can authenticate this thing. But what is missing here is the time where you submitted the message, right? And this is here we come in. You just take your signed message, submit it to their network. We attest it that at that particular time this message has been submitted, and you can actually prove that this was my message through the PGP, and that was submitted at that particular time. Actually, it takes, I think, like 2 days in a hackathon, and I think it will bring value pretty much immediately. But also, I'm sure that there are lots of creative ways to use a very simple things, just as simple as just timestamping in a very unpredictable way. So I encourage you to think about it and get in contact with us. So because we are open and support startups. So we really want startups to run our full node, not just like single developers. And we can help them to develop the idea into actually a small or maybe big profitable business. This is our incentivization problem. This incentivization goal. Yeah. Thank you for your attention. Yeah. By the way, don't forget to subscribe. This is my Twitter. This is Helix Twitter. This is Helix Telegram. Yeah. Yeah.
I think we still have 5 minutes for questions if you want to take some. If you have some. Does anybody?
Yeah?
You have to throw the cube. You have to throw the cube without.
All right. Yeah. Here you go.
Hello. Hello.
Yeah.
I was wondering if you could just walk through maybe kind of one more case where someone might want to use Helix, like it's kind of business-to-business cases.
Yeah, so as I mentioned, you can actually come up with many retail things. Another kind of interesting use case would be to integrate our Helix network with self-driving cars autopilot, so that actually it timestamps all the model states to the network, and once, for example, the network crashes, then you actually have leverage against Tesla and can sue it for $1 billion. And yeah. Because you actually have a proof that the thing was acting in a non-expected way, and you have timestamped on it. Yeah. And moreover, even today, Germany accepts blockchain record as a legal way to prove that that was at that particular time. Yeah.
Like, can you explain how this is fundamentally different from a globally available Kafka instance for?
Because in order to achieve consensus, you have to solve the Sybil. And you cannot solve the Sybil without either proof of work or proof of stake. That's why we actually need a coin here. And and globally, because otherwise you can spam your global Kafka with bots, and then you can do all the crazy stuff with that. You really need the consensus protocol in order to make it eventually consistent. Yeah.
Hi. So can you explain how is it better from a timestamping protocol on top of Bitcoin, say open timestamps?
Because it provides you much higher throughput and granularity. Because we have, in a Bitcoin, you have a single writer, right? Only the block producer can write in Bitcoin. But we actually are built on the DAG, and actually, to be real nerdy, it's a conflict-free data thing. So that actually everyone can write simultaneously, in concurrent writes. There is no need.
I mean, if we just take the task of timestamping data, we can put a bunch of data in a Merkle tree and put the Merkle root in one Bitcoin transaction once every 10 minutes.
But how would you do that if you have, for example, 1,000 writers? How would you do that? You would actually wait for a very long time before you submit your hash into blockchain. But in our case, all the 1,000 guys will be able to write it at the same time and get it on time. That's the point.
The question of security is still kind of, it may be faster, but is it actually comparably secure to proof of work like Bitcoin?
Well, it depends on right now it is proof of authority, so this is kind of automatic. Security comes from your adversary assumptions, right? And our second iteration, so as long as we get traction with our proof of authority thing, we will make it permissionless and proof of stake based. And in our case, we will have ERC20 for speculation. And in order to stake, you have to stake this coin, and you will be able to make the collateral even in Ethereum. And typically in such systems, the bottleneck, like security threat here, is that you can move pretty fast your funds, so that like there's nothing on stake attack. But as long as you have this bridge, which is not really emitted, you can always kind of separate, because our native coin will be mostly used for native staking, while the ERC20 will be primarily used for speculation and as a collateral hedge for those who will come from the Ethereum. But again, at that point, it is really like not that important, because as long as you get traction and you see how the people use it, you will get much more insights in there, because I mean, no need to have 1 million TPS if you have only one transaction, right, in the network. Yeah.
To your question, I also want to add that when you have this Merkle tree and then you put the Merkle root timestamped in the Bitcoin blockchain, then you still have the data availability problem, because you have to share this Merkle tree somehow off-chain. And that's actually not the same use case.
Yeah, in our case, you would typically also put some employ some compression in order to not spam the network. But the point is that once you put metadata in the network, then you can, for example, put IPFS handle, so then people use it. But this is still a problem with Bitcoin if you have 1,000 writers, right? Because it will clog the network. Only a single writer can put your Merkle tree in a single round, right? But yeah, you can just have everything on chain as long as the network. And because
how expensive is it? How expensive is it to put 32 bytes of data there? It's like a hash, right?
Right now it's actually free, because our model doesn't assume on-chain incentivization during the bootstrap phase, because our incentivization is as follows. So during the proof of authority phase, we have deals with vendors so that we onboard them in our network, and they provide added value services and implement use cases from our industry partners. And the incentivization is actually added revenue, and then we get some share, and they acquire, in order to get this, they acquire our HLX token. So it's like off-chain staking, so to speak, during the proof of authority. But later on, it will depend on your stake. The more you stake in HLX, the more quota in a round you have. Yeah.
Do you have an idea of what the cost is going to be, I guess, over time? It sounds like during the bootstrap phase that's handled, but like in the long term, do you know if you're a vendor that's using your protocol, do you have an idea of what your costs are going to be going forward?
What do you exactly mean by cost? Like using...
Publishing costs.
Oh, so we have fixed supply, and the Helix mesh protocol would work fine as long as we have less than 1,000 writers. So as long as we have, say, 10,000 vendors, the network will be actually quite cheap. So, and we don't actually expect that there will be much more. And right now the network usage, as I said, is completely free. And the point is that if we have 1,000 or 10,000 vendors onboarded in the network, the value from this network is so high that they will probably cover any added value cost just by delivering to the industry partners. Because even small integration has average check €100K. So that's why they actually have a very huge lever. It's B2B business is completely different from B2C. From B2C, you chase a very thin margin, 1 cent. But in the B2B cases, their mechanics are completely different.
So, 5 minutes ago, I received a picture of the barbecue grill that told me in 7 minutes it's gonna be ready, which means we still have 1 minute left.
All right.
Thank you, Dmitrii, for
Thank you for having me.